that introduction so much, I was forgetting I had to come up here and talk. Well, it's really a great pleasure for me to give a talk in honor of Harry Middleton. Before I ever met Harry, I had heard from several historians back east that he was running the best of all the presidential libraries here in Austin, and I am glad that his great tradition is being carried on by my dear friend Betty Sue Flowers in such a good fashion. The lecture on the origin of the universe. Why do we think there is such a thing as an origin of the universe? I mean, it's been around a long time. Well, if you look for old things, and when you find the oldest things you can find, they're all about the same age. And try as you can never find anything older than that. You begin to think that, well, maybe that marks some moment in the past when things began. And this is the situation we're in. Let's see, I'm supposed to open the laptop. Could you start the, let's look at some old things. Well, this is a cluster of stars called the Hyades. It's fairly close to us. It's visible to the naked eye, which is why it has a classical name. Tennyson, for some reason, called these the rainy Hyades. I never understood why. This is not a particularly old cluster of stars. How do we know that? Well, let's see, touch the space bar. There's a way that astronomers have of figuring out this sort of thing. This is a different picture of the Hyades cluster. In this picture, each point represents a single star, and the position of the point in the diagram reflects the temperature and the brightness of the star. Hot stars are over here on the left. Colder stars, as shown by their color, redder stars are here on the right. Very bright stars are up here, and dimmer stars are up here. So something in the center is sort of medium hot and medium bright. Here, upper left, very hot, very bright. Lower right, not so hot, not so bright. Now this has a profound implication, because the kind of theories that predict that there should be a multiverse also tell us that conditions will vary from one Big Bang to another, one explosion to another. Even what we call the laws of nature may not be universal laws of nature, but may vary from one part of the multiverse to another. And this suggests a possible answer to an ancient question, which is why are the conditions, the constants of nature and the laws of nature so arranged as to give rise to people like us? Why should it be that the charge of the electron and the mass of the electron and all that is so cunningly arranged that chemistry should be possible and carbon should form long chains of atoms and life should be possible? At first sight, this suggests a benevolent design, which is possible. But there's another possibility, and that is that this is just an accident. That in fact, conditions vary, as I say, from one part of the multiverse to another. And it's only in those parts of the multiverse, those big bangs, where conditions are suitable, where life arises. Maybe it only happens 1 in every 10 to the 500 universes. But wherever it happens, those are the only places where there are people asking this question. And so naturally they get the answer that the universe is very benevolently arranged. This is quite analogous to the even older problem, which is why is the Earth so well located so that life is possible? The physician Galen already noted, because he wasn't asking why the Earth was the center of the universe for him. He asked why is the sun located where it is. And he said the sun is located where it is because God put it there, because if it was any closer to us, it would be too hot for us, and if it was any further from us, it would be too cold. Now, if the Earth was the only planet in the universe, that would be a very sensible answer. In fact, it would be hard to think of a different answer. But we know that there are billions and billions of planets. That we do know, because most stars seem to have planets, and there are billions and billions of stars. And most of those planets, even here in our solar system, we see most of them are very inhospitable to life. You wouldn't want to live on Mercury or Pluto. You couldn't. You couldn't evolve there. And naturally, it's only on planets that are the right distance from their star, so that you have liquid water and good things like that, that there are people asking this question. So the fact that Earth is a comfortable place is not any kind of evidence for benevolent design. And it may be the fact that the laws of nature are suitable for life does not show anything one way or the other about a benevolent design either. In the New York Times in 2005, he said, now at the beginning of the 21st century, faced with scientific claims like neo-Darwinism and the multiverse hypothesis in cosmology, invented to avoid the overwhelming evidence for purpose and design found in modern science, that's a lie. The Catholic Church will again defend human nature by proclaiming that the immanent design evident in nature is real. Scientific theories that try to explain away the appearance of design as the result of chance and necessity are not scientific at all, but as John Paul put it, an abdication of human intelligence. Now, actually, I have a feeling that this was a trial balloon and has gone nowhere and has not been adopted as the official position of the church, I'm glad to see. But in a way, I was very happy to see this because, you know, we physicists and cosmologists sometimes get a little bit of envy of our friends who work in evolution because they get all this attention from fundamentalists, and you know, we get the feeling we're not doing anything important enough to make people angry. So it's one point about it. The theories that we have developed to try to account for things at really high density, really early times, seem to not be formulated with space and time as fundamental concepts. It's not unusual in physics that something you think is very fundamental you discover only occurs at a level of approximation. I mean, think of temperature. Temperature is something we all know about, and we think of it as having universal validity, the concept of temperature. The room has a certain temperature, the sun has a certain temperature. But you know, when you get to the level of an atom, the concept of temperature is meaningless. The concept of temperature is a statistical concept that describes what happens when you have lots and lots of atoms. And at the level of a single atom, the concept breaks down. It doesn't mean anything. You can't talk about the temperature of a hydrogen atom. In the same way, the very concept of space and time seems to break down when you try to consider densities beyond a certain point. And so, and space and time seem to only enter into our theories at a certain level of approximation. Of course, this makes it difficult to just use physical intuition to develop theories, because our physical intuition is hopelessly tied to ideas of space and time. It's one of the reasons that string theorists are stuck now, is because the normal intuition of human beings living in 3 dimensions and 1 time dimension fails them. But it may well be that the real question is not whether there was an instantaneous moment at which time began, but the real question that we have to address is how to understand nature under conditions in which time and space no longer have any meaning. I leave that.
Quick, give me your lighter.